Hello. Yeah, welcome to my final presentation on time value of money. And in this presentation, I want to finalize our discussion on uneven cash flows and take time to also look at different compounding periods. Because so far, if you remember, our focus has been where the compounding has been on a yearly basis. So we've been talking about 4% per year and compound being done on a yearly basis. What about the compounding is on a quarterly basis, or if the compounding is on a monthly basis or a semi-annual basis? So how do you go about in determining the future value or the present value? So we're going to look at some of the adjustments you have to make in a case where the compounding is not on a yearly basis but is on the other compounding periods, as we shall see later on. So when it comes to uneven cash flows, and I'm also going to look at or add into deferred annuity just to explain the two concepts. So when it comes to uneven cash flow, what we're referring to here is where the cash flows or the payments are not the same. Because with the annuity payments, we know that the payments are going to be the same. What about if the payments are not the same? And this is a clear example of what we're trying to do here. So assuming again, the compounding here is on a yearly basis, it's 4% per year, and we are talking about a period of 4 years. And you've been given a series of payments here where year one is $100 and the second cash flow is 300, and 300 is the third cash flow, and the fifth cash flow is an outflow of $50. So how do you go about in determining, for example, the present value of these cash flows? Because remember, with the annuity payments, if this was just $100 each period, if this was just 100 as we saw in the previous chapter, then it is very easy for us to compute the present value. Because if you use a calculator, we said you'll enter all other variables. So you'll enter n to be 4, you'll enter your rate to be 4%, and you're going to enter the PMT to be $100 if that was the case. But this is not the case here. Here is where you have 100 only in year one, and of course those cash flow changes over time. So to determine the present value, the use of the PMT $100 will not work. However, you can use the calculator to do the same thing. The only difference, you'll end up using the CFI uh, key on your calculator. This is basically the cash flow key, and you're going to have different cash flows. You're going to have, for example, a CF1 cash flow. This will be a CF2. You'll have a cash flow year 3, and you'll have a cash flow at year 4. And the first cash flow here at time 0 will be the cash flow at time 0, where it's going to be the cash flow 0. So in that case, you'll enter the cash flow 1 to be 100, cash flow 2 to be 300, cash flow 3 to be 300, and cash flow 4 to be $50 minus $50. And then you'll be able to use the net present value key. Again, you're going to enter the rate and the time, and you're going to have the net present value key, and you'll use this key to determine, of course, what the present value of these cash flows are. The other alternative of not using the CFI or the NPV on your calculator will be, you could do this on an individual cash flow. So what you do is you look at individual cash flow as a one-time payment, and you adjust the individual payment to the present value to times 0. For example, the $100 to be received a year from today, you're going to consider is we're receiving $100 a year from today. So this is going to be the present value of $100, where of course N is 1 because it's a year from today. So N is going to be 1 and I is going to be 4%. To determine that present value, you'll find this to be 96.15. So in other words, if you're looking at the present value, again by formula we say the present value will be the future value divided by 1 plus I raised to a power of n. In this example, for this particular $100 to be received a year from today, then your n will be 1, and of course your rate will be 4% and the future value. So you look at the $100 to be a future value. So a year from today, I'll be receiving $100. So 100 becomes a future value. So you insert this to be $100 and n to be 1 and rate to be 4%, and you find this again to be 96.15. And you can use a calculator to do the same thing. Just again, keep in mind you're looking at individual cash flow. The second cash flow, which is $300 from 2 years from today, in this case, again, your N is not 1, it's 2 years from today. So in this case, then we are talking about where N is equals to 2. So you'll use the same formula, or you can use a calculator, but then you're going to key in where your N is 2 and your rate is still 4%, and that will give you again, you're discounting the 300 into today's value, that should be 277.37. And you do the same thing for the third one. Again, this is in 3 years time, so your n is going to be 3. You change n to be 3. In that case, you find this to be 266.70. And the $50 is, this again, this is in 4 years time, so your n is 4. And again, you do this, you find that to be there. Then you add all the values. You add the present value of the first cash flow to the present value of the second cash flow. You also add the present value of the third cash flow and the present value of the fourth cash flow, and the total value of this is the present value of all the cash flows. And this is the same thing saying this is the net present value, which is going to be a discussion for us later on in the course when we'll be looking at different methods we use to assess and value investment projects. So we are going to use that NPV later on, but for now, the NPV can still work if you're trying to determine the present value of this cash flow. So in other words, we look at the present value of all the outflows and all the inflows and the present value, and we add them together, and that will give us a net present value, which is basically the present value of the inflows and the outflows. The other part I just want to add here, assuming, for example, instead of having what we call uh, 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 year one, you end up getting a payment in year one, assuming we skip year one. So, assuming you have a project, instead of having $100 in year one, you end up having $300 in year two. So, in that case, then is like we don't have that $100, so it's deferred. So, we're talking about a case where we don't have no payments either in year two or year three. If that's the case, then you can still find the present value of those cash flows, but instead of, because we don't have the $100, we are going to start this at year three. Again, this is n is going to be 3. So in this case, your n will be 2. Again, we don't have this, and therefore the present value of a deferred cash flow, where you don't have cash flow maybe in 1 or 2 years, initial years, but then you end up having a cash flow in later years, you use the same method. The only difference will be you don't have this cash flow, and therefore you don't have this present value. You begin your present value at the end of year 2, and therefore you'll have the 277, the 266, the 42, and you add them together. It gives you a present value of those cash flows if one cash flow was missing. So again, you do the same thing if that was the case. The other issue I want to finalize in discussing on the issue of present value and future value of cash flows is where how about if the compounding is not on a yearly basis? Because in all our computations here, we have been looking at where the compounding is on a yearly basis. So this is what we call on an annual basis. And we've been using the 4% in our case. And we have been assuming N, again, for argument purposes here, we say N has been 4 years. So assuming then that in this case is our compounding is not done on a yearly basis, our compounding is semi-annual basis, on a semi-annual basis. In that case, you're going to be given, of course, what the compounding is on a yearly basis. So if you stick with the first part here, if we stick with number one here, if that was the problem and you've been given it's 4 years and this is compounded again, instead of say compounded on a yearly basis, we've been told it's compounded on a semi-annual basis, but the rate is still 4%. If that was the case, then this changes what our N is, because remember, in a year, in 1 year, you will end up having instead of having one compound period, you'll end up having two compounding period, because you have every 6 months you're earning interest every 6 months. Again, this is over 4 years if that was the case, and therefore the total compounding periods in this case of a semi-annual basis is going to be the N is going to be the number of years we are referring to here, which in this case is 4 years, times how many compounding periods do you have in a year, which in this case is 2, and therefore this changes your N to 8. At the same time, in terms of this changes your N to be 8, so you have N compounding periods. In terms of your rate, instead of having a 4% is per year, we need a rate per period, and therefore we are talking about 4% per year, and we have 2 periods per year, and therefore this changes your rate to 2%. So in your computations, what you do is to use N to be 8 and substitute your rate to be 2% if that was the case. If the compounding again was different from, it wasn't semi-annual, let's say this in this case was on a quarterly basis. If this was done on a quarterly basis, then we are saying in 1 year you have 4 periods, because it's every 3 months you earn an interest. So that is the case. In 1 year you basically have 4 periods. So the total number of periods, so the total periods in this case then is going to be, you have 4 years is what we're referring to here, and you have 4 periods per year. So your total periods will be 16, and this will represent what your N will be. Similarly, your rate is 4% per year, but because you have 4 periods per year, it means then your rate per period, so your rate per period then will end up being the 4% divided by how many periods do you have in a year, and therefore you end up having 1%, and this will represent your rate or your I in your computation. So keep in mind that your N is going to change and your I will change if the compounding is not on a yearly basis. If it's done on a semi-annual basis, then you need to adjust your N, and you also need to adjust the rate. If it's done on a quarterly basis, you do this. If it's done on a monthly basis, then again you do the same thing. So if this was a case of compounding on a monthly basis, we have 12 months in a year, and therefore in that case, then your N total periods will be 12 months in a year times 4 years, and that will represent the total number of periods. And your rate will also change, and in terms of your rate, then you're going to take you have 4% given, and you have 12 periods in a year, and this will be what your rate is going to be. So keep in mind those values will change depending on what the compounding method are we referring to in any particular problem you're looking at. So I hope this information helps and concludes our discussion on time value of money. So you should have no problem in terms of computing time value problems. Again, the key idea from the start I said, make sure you draw a timeline, because the timeline is going to give you a bigger picture of what is happening, and you can enter the variables as you've been given in the problem, and then you can understand, or you can clearly see what we're missing and what we are trying to look for. So I look forward discussing these issues. If you have any questions, any concerns, please feel free to email, and see you next time. Thank you.